So having established that Pavlovian conditioning is a plausible model for ANV, we now need to know how to reduce it. This is unusual. Most of the time we're wanting to enhance learning or improve learning. In this case, we're wanting to actually reduce learning. Experiments with animals have suggested two ways in which we could do this, and they are overshadowing and latent inhibition. Overshadowing is when two stimuli are presented together, so for example a tone and a light, followed by the unconditioned stimulus, say an electric shock. If two stimuli are presented together, then less is learned about each of those stimuli than if they are presented alone. So if we have a light and a loud tone followed by an electric shock, very little is learned about the light compared with if the light was presented alone and paired with an electric shock. The presence of the loud tone overshadows learning about the light. This then provides us with one way in which we can try and reduce the learning about the hospital environment for patients undergoing chemotherapy. Here then is an experiment which looks at the effects of overshadowing on patients undergoing chemotherapy. We can see the very large graph which looks at the amount of post-treatment nausea for people who were given a salient, unfamiliar beverage before having their chemotherapy, that's the OV plus group, versus those who had a non-salient beverage, water, before having their chemotherapy. We can see in terms of the post-treatment nausea, those in the overshadowing group who had that salient, unfamiliar beverage are showing much less nausea than those who just drank water before their chemotherapy. This shows that giving that salient, unfamiliar drink has reduced the amount of nausea that people feel during chemotherapy. It looks like overshadowing is having an impact on people's nausea in chemotherapy. The second way in which we can reduce learning is something called latent inhibition. In the previous experiment I described, the drink which was given was unfamiliar. It's very important that stimuli, CSs, are unfamiliar. If an animal or a person is given a CS to experience a lot of times before it's used in an experiment, then people are very bad at learning about it. That non-reinforced pre-exposure reduces learning. This is why very few of you will have an aversion to beer. You have lots of exposure to beer before you drink too much of it and then become ill. So latent inhibition is a good way of reducing learning. In terms of whether this works with humans, studies have looked not with chemotherapy patients yet, but with normal students at the effects of acquired nausea. So these are experiments which are carried out in a university in Germany which is in a very large concrete building. You go down the steps and you go to a very particular, very distinctive environment. And then you sit in a chair which can rotate in 360 degrees. And you have 3 minutes of sitting in this chair being rotated through 360 degrees in all three planes. It's a very unpleasant experience which induces nausea. In the experiment which is here, there are 3 groups. Group 0 have exposure to a neutral environment for 3 days, and then 2 days of exposure to the rotation chair before giving their baseline rate of rotation when they go to the rotation chair room. Group 1 have 2 days of exposure to a neutral environment, followed by a day's experience of the rotation chair, where they walk down to the rotation chair, sit in it, and have nothing happen. Then 2 days of actual rotation, and again they give their baseline ratings of nausea. Group 3 have 3 days of exposure to the rotation chair, then 2 days of actual rotation, and then again give their baseline rates of nausea. So these 3 groups have the same amount of conditioning. They have 2 days of the rotation chair, and then they give their ratings of nausea. The difference between the groups is how much experience they have of the environment of the rotation chair in advance. If we look at the data at the bottom, we can see that those people who are in group 0, that is, they have no exposure to the rotation chair before undergoing the rotation experience, acquire a lot of nausea symptoms when they go and sit in the chair to give their baseline readings on the last day. However, groups 1 and 3, which have the pre-exposure experience, are showing an equal amount of nausea, but not very much. It's much less than group 0. So it looks like there is an effect of pre-exposure to the rotation chair that reduces the ability of the rotation chair context to evoke or to become associated with nausea. So in summary, Pavlovian conditioning is a ubiquitous process. All animals do it. By studying Pavlovian conditioning, we can study basic learning processes. One of the features of the study of Pavlovian conditioning is that it has very well-defined theories that enable us to make very testable predictions. It can allow us to address problems which are central to human cognition. It doesn't just apply to animals.